Here in section 4.9, we are working with applications of rational equations. So we're going to be solving similar equations to what we did in section 4.8, but this time we're going to be working with setting up our own equations, looking at the word problems. So in the box right here, we have what we call working together problems, and the equation that we're going to use for all of them will be exactly the same setup every time. We're going to be working with the reciprocals of everything that's mentioned throughout the problem. We're going to have two objects or two people that work alone, and we're going to add the alone times together. But we're going to work with the reciprocals of the alone times, so we're going to sum the reciprocals together. And then on the other side, we're going to have the times that they're working together, and we're going to work with the reciprocal of that. So we sum the reciprocals of the alone times, and we're going to set it equal to the reciprocal of the working together times. Why do we work with the reciprocals? So here's the idea. Let's say that I would like to paint a wall, and let's say this wall from start to finish takes me 3 days to actually paint. So if I paint the entire wall, let's say it takes me 3 days. Let's say that I'm working at the same rate the entire time, the entire 3 days. How much could I actually complete in 1 day? Well, in 1 day, let's think about, we're going to take this wall, we're going to divide it into 3 equal parts. And in 1 day, I would actually complete a third of the job. So I can paint a third of the job, a third of the wall in 1 day. If you think about it, the entire project takes 3 days, and how much can I complete in 1 day? That's what we're looking at. And these two numbers are reciprocals of each other. So in the first problem, for example, we're looking at two people that are painting a home. So it says Elmer can paint his house in 4 days. So I'm going to write down Elmer, and we're going to write down the time that it takes him working alone. And this is his alone time. If he's painting alone, he can do the entire job in 4 days. If John is working completely alone, John can actually do the whole job in 12 days. Now, it says Elmer's using a spray painter, but John is using just a paintbrush. So it takes John 12 days to actually paint the entire house. Together, so we're going to have alone times, so how much it takes for each one to do it alone, and then we're going to have a together time. Together, how long will it take them to paint the house? Well, I don't know, so we're going to call that X. What we're really looking to do is to put everything in terms of how much can each person, how much is each of these within 1 day. So in 1 day, how much of the job can Elmer finish? Well, he can paint 1/4 of the house. So we're looking at what gets accomplished in 1 day. Plus John, if he works for 1 day, he's going to finish only 1/12 of the house. Now, if they work together, they can finish 1 out of X amount of the house in 1 day. So the whole entire equation is in terms of what happens for each person alone and together if we are narrowing it down to just what gets accomplished in a single day. Now we're going to solve the equation using the techniques that we talked about in section 4.8. We have a variable and a denominator. We want to get rid of all the fractions at the beginning by multiplying everything by the LCD. And our LCD is 12x. So we're going to multiply every fraction and every term on both sides by 12x. And then we're going to reduce each one of those multiplications. So we have 4 goes into 12 3 times. So for that first simplification, we're left with 3x. For the next one, we have 12 goes into 12 1 time. So we're left with just x equals. Notice I brought down my plus sign and my equal sign. And then on the other side, x and x cancel, so we're left with just 12. So now we have an equation with no fractions in it, which is exactly what we want. It's a linear equation because x is just raised to the power of 1. So I'm going to add my like terms, and then I'm going to divide by 4. So what does x represent? Let's go back to our representation section. X represented the number of days it would take if they worked together at the same time, simultaneously painting the house. It would only take them 3 days. So essentially what we're saying is that if they worked together in that one day, it would take them, they would actually finish in that one day, they would finish a third of the job in one day. So that'll take them 3 days working together simultaneously to paint the entire house. All right, let's look at the next example. Here we have a water tank that's being filled by 2 inlet pipes. I'm going to write out kind of the information as we go. Pipe A, and this means pipe A working alone. If I turn pipe A on alone, it will take 45 minutes to fill up the tank. Pipe B and pipe A working together, it tells me that if they work together, they can fill the tank in 20 minutes. So I don't know how long it takes pipe B alone, but I know that together, if they're both on at the same time, it'll take 20 minutes to fill up the tank. How long does it take to fill the tank using only pipe B? So if pipe B works alone, and I don't know that, so we're going to say that's X minutes. So to set up the equation, we want to know what can be accomplished in 1 minute. So how much of the job can pipe A do in 1 minute? Well, it can do 1/45 of the job. So we're going to work with the reciprocal of all the information that we have. Plus, pipe B can finish 1 out of X of the job, working with the reciprocal of pipe B's information. We're going to add those reciprocals together and set it equal to the time together, but working with the reciprocal of the time together. So if they work together, they can finish the job in 20 minutes. So in 1 minute, they can accomplish 1/20 of the job. All right, once we have our equation, we are going to use the techniques we learned about in section 4.8. We're going to find the LCD, and we're going to multiply every term on both sides by the LCD. Now, if you don't know what the LCD is, just by looking, you can always come to the side and use the techniques that we talked about with finding LCDs. Okay, we're going to factor into primes. So in this case, if I factor 45 into primes, I get 9 and 5, which is 3 times 3 times 5. X is already factored into primes, so we'll just write X. And then 20 would be 4 times 5, which is 2 times 2 times 5. So these are all my prime factors. We want to multiply in exactly what we need to each one to make them match. So the 45 has a 3, it has a 3, and it has a 5. This neighbor has an X that it doesn't have, so we're going to multiply in a missing factor of X. The neighbor down the road here, the 20, has a 2 and a 2 and a 5, and so we need to multiply in the missing 2's. If I work from the perspective of X, X is missing all of the numbers that its neighbors have. So it's missing a 3, and a 5, and it's missing a 2 and a 2. Okay, so notice that it has everything that the 45 has now. The 20 is missing a 3 and a 3. It already has a 5, so it doesn't need a 5 that the other two have, and it's missing an X. It doesn't have the X that its neighbor has. If I multiply all of these together, all of these now should be the same. I should get 180x. Once they all match, they have all the same factors, then that value, all those values multiplied together would give me our LCD. So we're going to multiply everything on both sides by 180x. And you can think about that as 180x over 1. You can multiply this fraction times all of the terms on both sides. Okay, and then we're going to start to reduce. 45 goes into 180 4 times. X and X for the middle will cancel. I brought down my plus sign there. So I'm left with 180 equals. Brought down my equal sign, and then 20 goes into 189 times. So that leaves me with 9x. Now we're left with a very simple equation to solve. Just solve for x. It's a linear equation, so I don't have to factor. So we're just going to subtract 4x from both sides. I'm left with 180 is equal to 5x. Then we're going to divide both sides by 5. 5 goes into 180, actually get 36. Okay, if you're in doubt about that, you can always do the long division. 5 goes into 180. You first do 5 goes into 18 3 times. Subtract off the 15. Oops. Okay, and 18 minus 15 is 3. Bring down the 0. 5 goes into 30 6 times. So you can always do the long division if you're having trouble with figuring out 180 divided by 5. So we get x equals 36, and let's go back up to our representation section. That means that pipe B can actually accomplish the job alone in 36 minutes. All right, let's look at this next example. Working alone, George can wash his car in half an hour. So I'm going to write down the information for George. If George and Sarah work together, they can wash his car in 20 minutes. So we also have information about Sarah, and we have information about them working together. So we know that together it will take them 20 minutes. How long does it take Sarah to wash the car alone? So that's what we don't know. That's what I'm going to call x. Now, we don't know if it's hours or minutes. We need to change it to be all in terms of either hours or minutes. I'm going to go ahead and change half an hour into what it represents in minutes. Half an hour is 30 minutes. Okay, so we're going to change everything to be in terms of minutes. So x represents how many minutes it takes for Sarah to work alone. So we have 30 minutes, x minutes, and then 20 minutes. So our equation will be the alone times, and we're working with the reciprocals of the alone times. So 1 over 30 plus 1 over x is equal to the reciprocal of the together time, which is 1 over 20. This one is a little bit easier to see, our LCD. 30 and 20, we know that that would be 60, and then we also need an x. So we're going to multiply everything on both sides by 60x, and you can think about that as over 1 if you wish. Okay, and then we are going to start to reduce. So 30 goes into 60 2 times. That leaves me with 2x. Bring down my plus sign. X and x cancels. That leaves us with 60. And 20 goes into 60 3 times, so that leaves us with 3x. Now this gives us a really easy equation to solve. It's a linear equation, so I just need to get x by itself. I'm going to subtract 2x from both sides. I end up with 60 is equal to x. So if I go back up to my representation section, that tells me that it takes Sarah 60 minutes to actually complete the job alone. All right, in our last example here, we're told that it takes Mark twice as long as Mary to dust the house. So I'm going to go ahead and just start writing Mark and Mary. And working together, they can dust the house in 6 hours. So here's my together time. How long does it take Mary to dust the house alone? So we don't know how long it takes Mark, and we don't know how long it takes Mary. But we do know that it takes Mark twice as long as Mary. So if it takes Mary X hours to dust the house, it's going to take Mark twice as long. And we know twice means to multiply by 2. So if it takes Mary X number of hours, it's going to take Mark twice as long. So we're going to say it'll take Mark 2 times X hours. Now we're going to set up our equation. We're going to work with the reciprocals of the alone times. So it's 1 over 2x plus 1 over x. We're going to set that equal to the reciprocal of the together time. So this is our equation, and we want to solve it by multiplying by the LCD. So we have 2 and 6, so the LCD there would be 6. And we need x here, here, and here, so we'll multiply by 6x. So I'm going to multiply everything on both sides by the LCD over 1. And then we're going to simplify as much as we can. So we have an x and an x, so those cancel. 2 goes into 6 3 times. So here we're just left with 3. Bring down the plus sign. Now x and x cancel, so we're left with 6 equals. Bring down the equal sign there, and then 6 and 6 cancel, so we're left with x. And this is the easiest equation that we've solved of them all. 3 plus 6 gives us 9, and then we're immediately solved for x. So this means that it takes Mary 9 hours to actually dust the house alone. And of course, then if it takes Mary 9 hours, it'll take Mark 2 times 9 hours, so it takes him a total of 18 hours to complete the job. And we were only asked for Mary's time, so Mary's time represents 8 hours.